Alright, a little bit more with integrals for recap lecture number 4. Hopefully the mean value theorem went okay for you, and we are ready to talk about using some graphs to help us evaluate some integrals. So we have the graph of f of x, and it says to evaluate the integral from 1 to 7 of f of x. Well, we don't know what f of x is, but we do have the ability to use some geometry to help us. So if I break this up into this rectangle here, which has a width of 6 and a height of 1, this whole area is 6. This triangle is 1/2 the base, which is 1, times the height, which is 2. So this is 1. Same thing, this triangle, 1/2 the base, which is 2, and the height, which is 1, is going to also be 1. So our part A, the integral from 1 to 7 of f of x, is just going to be equal to 8 units. Part B then says find the average value. Remember, average value, f is what goes in the integral itself. So 1 over b minus a times the integral from a to b of f of x dx. Oops. Instead of a to b, how about I actually plug in those bounds? That would be a good idea. Alright, well, we just saw that our integral from 1 to 7 is equal to 8, which means it's going to be 8/6 or 4/3. That's the answer also. Alright, so then part C says determine the answers to part A and B if the graph is translated 2 units upward. So really what we're looking for here, mathematically, is we are taking the integral from 1 to 7 of our function that's been shifted up 2 units. Okay? So we can do this mathematically, and we can say our integral from 1 to 7 of f of x, this part we knew was just equal to 8, and then we can add to it the integral from 1 to 7 of 2, right, because you can break this up across the addition. So the integral from 1 to 7 of 2 would be 2x evaluated from 1 to 7. Running out of room. So this will be 8 plus 2 times 7 is 14 minus 2 is going to be 12 for an area of 20. So that's kind of mathematically and calculus-wise the way to think about that shifting up 2 units. The other way to think about it is you're taking this entire graph and you're moving it up 2. So really what you're doing is you're inserting this big rectangle that's 2 units tall and 6 units wide for a total of 12, right? And you kind of like pushed it up in there. So you can also get to your geometric answer that way. So that's part A, redone. Part B then it says the average value for that same function. So average value is just going to be 1 over 7 minus 1, the integral from 1 to 7, of our function that's been shifted up 2 units. We just talked about 2 different ways to evaluate this integral, but either way you're going to end up with an area of 20 times 1/6. So we get 26 or 10/3. Alright, last one then. It says use the graph to find the different shaded regions. So we've got region A, which has an area of 1.5. That's the part down here below the x-axis. We have region B, that has an area of 3.5. Just kidding. 0 to 6. The whole thing has an area of 3.5. Not just part B. So if I want to look from 0 to 2, that's going to be this part right here. We know that it has an area of 1.5, but that area is being calculated by moving to the right and then downward. So this is actually going to count as negative 1.5 because you'd be taking positive widths and negative heights. Then we want to go from 2 until 6. Well, we know the integral from 2 until 6 is the same thing as b, and we know that a plus b is equal to 3.5. We just determined that our area A was negative 1.5, which means that our area B from 2 until 6, we're going to add that 1.5 to the other side, and be equal to 5. Okay. Next one then, the absolute value of f of x. So absolute value just means that anything that lies below the x-axis is now flipped above the x-axis. So when you're talking about 5 that we just found for number 6. That's going to be a total of 6.5. From 0 to 2, with negative 2 times f of x, we can take out that constant multiplier. This we already answered is negative 1.5 times negative 2. 2 plus, we can split this up into 2 separate integrals from 0 to 6. 2 plus the integral from 0 to 6 of f, we're going to end up with 15.5. And then we had from 0 to 6 was 3.5. The integral from 0 to 6 of 2 is going to be 12. 12 plus 5 is 2. So we need the average value of f. So that means that f is what goes inside the integral from 0 to 6. Like writing it. Okay, we would like to find that average value. Well, we know the integral from 0 to 6 was equal to 3.5. We got 1 over 6 being multiplied on the outside. 3.5 is the same thing as 7 halves, so we're going to end up with 7 twelfths for our final average value. Alright, that should conclude our recap lecture number 4.